in this problem, we have two members, AB and AC, joined together at point A by a pin, and they form a frame, and the frame is supported by a pin support at point B and a pin support at point C. And we need to determine the support reactions at B and C. So the frame is subjected to a 200 Newton force acting on member AC, not on the pin, 120 Newton force also on member AC, and also a distributed load along member AB, which can be replaced by a concentrated force with a magnitude of 60 multiplied by this length right here, which is 1.2 times square root of 2, and that equals to about 101.8 Newton. So we start with drawing the free body diagram of this entire frame. And we have 200 Newton here, 120 here, and 101.8 Newton here. And because we have two pin supports at B and C, each pin support has two support reactions, BX and BY here, CX and CY here. So this is the free body diagram of this entire frame. And from here, we know that one 2D rigid body free body diagram enables us to write three equilibrium equations to solve for three unknowns. But we have now four unknowns, so we cannot solve for all of them. Which means that we need additional free body diagrams. We can certainly solve this problem by drawing free body diagrams of member AB and AC separately. So if we do that, free body diagram of AB subjected to 101.8 Newton force right here, and at point B we will have the support reactions BX and BY just like before. Here we will have another pair of support reactions because point A is also a pin, so AX and AY. So that's the free body diagram of member AB. And then if we draw the free body diagram of member AC, it's subjected to the 200 Newton force right here, 120 right here. We also have the same CX and CY. But at point A, instead of introducing new unknowns, we should recognize that the forces here are going to be equal and opposite with these two. And if you've watched the lecture video, you know that these are not action and reactions, but they can be considered so. So if you have two members being pinned together, because of the equilibrium of the pin, it is okay to consider these two forces are action and reaction, and these two forces are action and reaction because they have this equal and opposite relation. Even though member AB and AC, they do not directly interact with each other. They interact through the pin. But anyway, with that knowledge, now we have two free body diagram for member AB and member AC. So overall, two rigid body free body diagram gives us overall 6 equations, 3 from member AB and 3 from member AC. And as you can see here, we have 6 unknowns as well. So we have AX, AY, BX, BY, CX, CY. Therefore, we are confident that we can solve this problem if we draw the free body diagram of the member separately and then combine the equations to solve for the unknowns. So that's definitely doable, but maybe there's a faster way. If we come back to free body diagram number 1, we realize that if we write the equation, resultant moment about point C, because the three unknowns Bx, Cx, and Cy, they all have lines of action passing through point C. They do not create moment about point C. In fact, for this force right here, it also has line of action passing through point C. Therefore, the only unknown that has moment about point C is By, creates clockwise rotation, negative By times moment arm of 1.2. And then the two concentrated forces, these two, they both have moments about point C. So from there, we can solve for By. By equals to 260 Newton. And if we do the same thing, summarizing the moments about point B, out of the four unknowns, Cy is the only one that has moments about point B. So from there, we can solve for Cy, which is negative 188 Newton. So as I said earlier, from this free body diagram, we cannot solve for all the unknowns, but we can solve for some of them. And then if we already know what so these two were solved using free body diagram number 1. And then if we look at free body diagram number 3, we realize that, so this is number 3. We realize that we can solve for Cx from free body diagram number 3 by summarizing the moment about point A. Because Ax, Ay, and Cy, they all have moments about point A. So this equals to, this 200 Newton force also have moment about point A. So only negative 120 times 0.6, and then plus Cx times 1.2, and that equals to 0. So from here, we can solve for Cx, which equals to 60 Newton. At this point, if we go back to free body diagram number 1 and then summarize the force along the x direction. So from the free body diagram number 1, we have Bx plus 101.8 times square root of 2 over 2 and minus 200 minus 120, and then plus Cx, 60, equals to 0. So from there, we can solve for Bx. And Bx equals to 188 Newton. So from there, we can solve for the resultant force, Fb equals to square root of Bx squared plus By squared, and that is 321 Newton. And lastly, Fc equals to the resultant force at point C, and that is 197 Newton. So as you can see, using this method, we only need to write 4 equations instead of 6 equations. And we didn't have to solve for the intermediate Ax and Ay reactions. And also, the best thing about this method is that, as you can see, in each of the 4 equations, there's only one unknown, so it is relatively easier to solve.